Okay, today's the last day of factoring. Review tomorrow, test on Thursday. Today we're going to do factoring special cases. First one is a perfect square trinomial. So the idea is we had special cases when we were multiplying, where you multiplied it out and you got a perfect square. You do not need to necessarily factor using the shortcuts I'm going to show you, but it's a good idea that you see them. It helps. But we're going to do factoring perfect squares. And the other one we're going to do, and this is the one that is much, much more important for factoring purposes, the difference of two squares. So we're going to factor perfect squares. We're going to factor the difference of two squares. The big X will work on these, but seeing the difference of two squares in particular will be extremely helpful if you can recognize it and do that one. Okay, the shortcut is much, much, much bigger on that one. Don't think you should have come sooner. At least it's wearing. Right. Okay, so this first one here, I can factor just by using big X. Not a problem, right? Take the first two numbers and multiply them. I get 64. Bottom gets 16. I want two numbers that multiply to give me 64 that add to give me 16. 8 and 8. This is a perfect square. This is 8 squared. This is what I'm talking about being a perfect square. I put 8 and I put 8. Right. What do I have in front? I have 1K. So I put this over K. I put this over K. And my answer is K plus 8 times K plus 8, which is K plus 8 squared. That's what we're trying to do. Okay, now, if you did not put the K plus 8 squared, but you had K plus 8 and K plus 8 on the test, I would not mark you wrong. But you need to start seeing some of these things. Notice that that is K plus 8 times K plus 8 is K plus 8 squared. That's what we're trying to do. Remember we had, a while ago, you went from here to there. Now we're going back. Okay, and understanding the shortcut for multiplying helps with the shortcut for factoring. So if I want to take a look at the shortcut, I go, okay, wait a minute. This is a perfect square. This is W squared. This is a perfect square. This is 4 squared. 16 is 4 squared. I have a square in the front. I have a square in the back. Is this whole thing a perfect square? Here's what you do. You take this number, 4, and double it, see if you get the one in the middle. Or actually, I should say, you multiply these two, which gives me 4W. Is 8 twice that? Yeah. So that means I have a perfect square. I have W in the front. I have 4 in the back. And then plus or minus in between. That comes from that term right there. It's a minus there. It's a minus there. So that's the shortcut. Square, square. Ooh, those are both squares. It might be the factoring of two squares. I have to check the middle term. Once again, You can do it by the shortcut. Or you can set up the big X. Either way will work fine for you. Okay. So this one here, I have 36 on the top, negative 12 on the bottom. This is a perfect square, right? 36 is 6 squared. Is 6 plus 6, is that going to give me 12? But what does it need to be? It needs to be negative 6 and negative 6. So this is going to be a perfect square. Put it over x, and I get x minus 6, x minus 6, which is x minus 6 squared. Okay? This next one, same thing, but I want to look, okay, is this a perfect square in the front? Yeah, 4 is what? It's 2 squared, right? So that's 2x squared, and 9 is 3 squared. So I'm suspecting that this is a perfect square, so I can do that. I want to think, is that what I'm going to get? I can set up with the big X and still do the same thing. What's 4 times 9?
36.
And what do I have in the bottom? Same two numbers I had here, right? And what do I divide them by? I divide them by 4x. And what happens? This reduces, right? 3 over 2x. 3 over 2x. This is, both of them are the same, right? 3 over 2x, 3 over 2x, which means I have bottom and front, top and back, and it happens twice. Okay, questions? Okay, these are a little bit more challenging, but if you recognize the pattern, it works perfectly. If I were to use the big X on this, what goes on the top? Negative 81. What goes in the bottom? No. 0, because how many X's do I have? I don't have a middle term. Where does the number in the bottom come from? It comes from the middle term. This is one where it's tricky. This is very tricky to use the big X on because students don't see a middle term, but they think, oh, well, the second number goes in there. It's not the second number. It's the middle term. Don't have a middle term. Don't have an X. So it's supposed to be a 0. This doesn't work well. What works better is this a perfect square? Yeah, I'm taking X and squaring it. Is 81 a perfect square? Yeah, it's 9 squared. What's in between them? A minus, right? If I have a minus in between, a square minus a square, that means I have square root of the first minus the square root of the second, square root of x. Sorry, this should be a 3. Yeah, no, sorry, 9. Boy, I screwed that one up, didn't I? I know, I started out just freaking fine. And I blew it. So I have x minus 9, x plus 9. Square minus the square, square root of the first, plus and minus the square root of the second. That's how it factors. Remember when we multiplied these, no middle term? Okay? If you don't have a middle term, if you only have 2 terms, this is most likely, but not guaranteed, most likely what you're going to have.
If you don't know your perfect squares, you have a square root button in here. Second, and then the x squared button will give you the square root of 81. Which is 9.
Yes. I look at the second one, 9x squared. Well, 9 is a perfect square, right? That's 3 squared plus the x, so I have 3x squared gives me 9x squared. What about 25? It's 5 squared. So a square minus a square, I have 3x minus 5, 3x plus 5. Shortcut works wonders on this one. Really makes it so much easier to do the shortcut on this one. Same thing on this one here. Y squared, so that's y squared. What about 49? 7 squared. Square minus a square, y plus 7, y minus 7. Notice I swapped the plus and minus, doesn't matter as long as it's one of each. Okay. So 49 c squared. Well, 49 is 7, and then c squared is c, so I have 7c. What about 1? Is 1 a perfect square? Yeah, 1 times 1. 1 is a perfect square. It's a perfect cube. 1 is a perfect anything. 1 times itself no matter how many times. So I have 1 squared. So I have 7c minus 1, 7c plus 1. The shortcut on this one is everything. It is absolutely everything on this one. I only have 2 things, and I have a variable in the first that's squared, and I don't have a variable in the second. Look at what I have. If it's square minus square, look to recognize that. If you recognize this pattern, it's easy. If you don't, this is the one that's going to catch you if you're not paying attention, if you're not careful on this one. This is the only one where the shortcut really makes any difference whatsoever. Okay? Any questions?